All right, guys, for this video, we're going to talk about reverse engineering. So what is reverse engineering exactly? Well, basically, it's what it sounds like. It's engineering backwards. Rather than starting with an idea and ending up designing a product, in reverse engineering, you take something that already exists that maybe you don't know a whole lot about, and you analyze it. You break it down, you figure out all the little details, and eventually you figure out how and why was it designed the way that it was. So we do this for a few different reasons. First off is documentation. So maybe it's something that's existed for a while and we kind of take it for granted, but we don't have any documentation on it. Or something's broken and we need to be able to fix it. We need to be able to do maintenance on it. A big reason also is discovery. So for academic purposes, for research, for learning, reverse engineering the brain is a great example. Obviously, brains have been around for a long time, but it's something that we don't know a whole lot about. And even after completing the Human Genome Project in 2003, there's still a lot we do not know about the brain. For some people, it's also just a matter of curiosity. If you're one of those people who likes to take stuff apart and tinker with it just to see how it works and then put it back together or not, that's a great example of reverse engineering. Military or commercial intelligence is another great example. Somebody comes up with something, whether it be a stealth plane that gets shot down in enemy territory, and their goal is to capture the plane and then reverse engineer it to figure out how did they design it to do what it did. What makes it so lethal? What makes it so stealthy? What makes it so fast? I think I saw a movie one time, and the plot of the movie was the mission to go find the plane and not save it, but destroy it, so the enemies could not get their hands on it. Also, there's investigation. So maybe you have a competing product that's beating you out, and they've come up with something that you don't have. So you can investigate it and figure out what is their secret sauce, what's their special recipe, what are they doing, and how can we replicate that, or better yet, improve it to beat them. You can also figure out if somebody copied you. You can document the patent infringement and prove that they're doing it the same way that you are, and you've got the documentation to beat them legally. And then lastly, there's some design failure. Let's say a bridge collapses, which is an awful tragedy. Sometimes people would die, huge money loss, and they can do some reverse engineering to figure out what caused the bridge to fail and ultimately whose fault is it. And then lastly, and I think most importantly, it's to improve or redesign something. And this is where this ties back into design. So here's some tools that you would use going back to low-tech things. Not that micrometers are low-tech. Then you got calipers, a little bit more high-tech version of that. And then some more modern things like medical imaging. Super important. Looking into the body and figuring out how things work and then what's wrong. Then once you figure out what's wrong and what's causing the problems that you see, you can work on designing things that try to help solve those problems. And then here's a 3D scanner that you can pair with a 3D printer. Once you 3D scan something that already exists, then you're able to 3D print replicas of it, which I think is pretty awesome. So there's 3 stages of reverse engineering that we want to talk about. And if you're one of my students, these are 3 things that you are absolutely going to be expected to master going forward. So we've already talked about the visual analysis. So for this one, we're going to focus on the functional and the structural. If you missed out on the visual analysis, there is another video. I'll post a link in the comments below. So first up is functional analysis. This is pretty straightforward. Your goal is to explain how the object functions, which starts off with what's the point, right? What's the purpose of the object? What is it supposed to do? What problem is it supposed to solve? Then you go into some more detail about how it actually does that. So I'm going to go through an example with you. We're going to go with an electric toothbrush, okay? So the purpose of this toothbrush, or any toothbrush, is to clean your teeth and gums to prevent things like tooth decay, cavities, gum decay, gingivitis. The way it works, it uses an electric motor that makes the toothbrush vibrate, and this vibrating motion then cleans your teeth similar to a normal brush, only with less effort, which my screen decided to cut off here. The less effort part is key because, we're humans, we're lazy, Moving our arm back and forth is just too much sometimes. So that was the functional analysis. Like I said, pretty straightforward. Next up comes structure. So the structural analysis is where we start to talk about, okay, physically, how does it accomplish that purpose? What is it made up of? So your first step is going to be to draw it out. An even better way to do this would be to use a 3D model where you can replicate the actual design the best you can. And then here's the key. Make sure that you annotate it, just like you see here. Honestly, this picture just about speaks for itself. Next up comes the part description, a little bit more detail. So not only is this what it is, but why is it the way it is? So the neck and head resemble that of a regular toothbrush because we're comfortable with regular toothbrushes, so they don't want to change it too much. The brush is battery operated so that it's easier to use. That way you're not having to deal with a cord or a plug or anything. The handle's ergonomically designed to fit into your hand and be comfortable. You got some padding where you grip it. And the buttons are placed in a spot where it's easy to press them while you're holding the brush. Your thumb is going to wrap right around here, so it's easy to push that button while you've got the toothbrush in your mouth. And then lastly, the battery can be charged, saving the owner money. It's not like you're having to buy AA batteries every few weeks to replace the batteries that you're using. Okay? There's a switch right here and then a battery, and you can plug it in down here at the bottom. Okay? So this is the part description for your structural analysis. So to recap things, guys, there are 3 types of analysis that we discussed. There's visual, which we went into a lot more detail in my other video. And then today we talked about functional and structural. Guys, it's super, super important to be able to complete a thorough analysis of an object. Just like we saw the example in the previous slides, maybe in a little more detail. And why this is so important is because it can be a springboard for innovation, right? If I was looking to design a better electric toothbrush, what better place to start than here? Looking at this annotated sketch, looking at why things were done the way they were, maybe I can decide something like, you know what? I've used an electric toothbrush and it really doesn't clean my teeth. Or, it's not very comfortable. Maybe it's too heavy in your hand compared to a regular toothbrush. We can start looking at things that we can change to solve problems like heavier or not cleaning my teeth or battery dies too often or, so on and so forth. But to be able to really improve and innovate on products, you've got to be able to do your structural and functional analysis first. Okay? Guys, I hope you learned something today. If you have any questions about this video, please drop a comment below. And before you leave, please click that subscribe button. See you soon.